What's up everyone, Patrick here, welcome back. And in this next video, what we got to do is take these inequalities here and we're going to graph them. So starting with number one, we got x minus 3y is less than or equal to 12. Now, the way that I personally like to do something like this is I like to isolate for the y. So put it into y equals mx plus b form, because then you can graph the line and basically then the shaded region is going to be either above or below that line. So what we can do to isolate for this y, I'm going to bring the negative 3y over to make it positive, and then I'll bring the 12 over, so I'll have x minus 12 is less than or equal to positive 3y. So then dividing everything by positive 3y, it allows us to keep that sign there. We don't have to worry about flipping it. And so we would end up with 1 over 3x minus 4 is less than or equal to y, or y is greater than this. So another way to write it is y is greater than or equal to 1 over 3x minus 4. Now, if you kept the negative 3y on this side and brought the x over, so negative 3y is less than or equal to negative x plus 12. Bringing this over turns into a negative x. And then when you divide everything by negative 3 at this point, you have to flip that sign when you're dividing or multiplying by a negative number. So what would happen is y would end up being, you flip the sign, greater than or equal to positive 1 over 3x, right? The negatives here cancel out, minus 4. So whichever way you go about it, you get to that same ending point. And then what I do is I graph this line here, 1 over 3x minus 4. So notice the b value is negative 4. So we got 0, negative 4 as a coordinate. And then the slope is 1 over 3. Another thing you could do is you can, let's say we had this line, y equals 1 over 3x minus 4. You could solve maybe for the x-intercept. So you could plug in 0 for y and then solve for the x. So you'd end up with 4 equals 1 over 3x. Multiply both sides by 3. So x would be 12. So the x-intercept is 12 and 0. Right? You don't necessarily have to get the x-intercept. You could just get another point. So for example, if we started at 0, negative 4, we know the slope is 1 over 3. Well, we can rise by 1 and then run by 3. So this point here would end up being, we rose by 1, ran by 3. So this would end up being 3 and negative 3. That's a line, or that's a point that's on this line over here. So that's another thing you could have done. But personally, usually I like to just get the intercepts and then just connect those two dots. And the intercept for this line here, the x-intercept is 12, the y-intercept is negative 4. And so from here, you can connect these dots. So it's basically this line over here. And because it says y is greater than or equal to this line, it's basically all of the y values that are above this line here. And so the shaded region would basically be all of this over here. Right? And this keeps going up until infinity. So it's basically all of this here. Another way that you can test your solution is you can pick a test point within that region that you shaded. So an easy one to pick is 0 and 0, the origin. And then you can plug it in here and see whether that point does satisfy this inequality. So notice if we plug in 0 for x, 0 for y, we'd end up with 0 on this side, and 0 is indeed less than or equal to 12. And then if you want to test this region where the solutions are not located, so you could test a point like 0 and negative 5, for example. We know that that, according to what we got, shouldn't be a solution to this inequality, well, notice that if we plug in 0 for x and then negative 5 for y, we'd have 0 minus 3 times negative 5, which is positive 15. 0 plus 15, notice that 15 is indeed not less than or equal to 12, right? This here doesn't make sense, and so 0, negative 5 would not be a solution. Now, a couple of things. What if this was flipped? What if we ended up getting this, which means that this here would be flipped, right? This was like a greater than or equal to sign. This is the solution that we would end up getting. Well, if this was flipped here, it'd be all the y values below the line. So this area here would be shaded. Because it was all the y values greater than or equal to that line, it's all the y values here. Another thing I want to mention is that because it's greater than or equal to, this here is a solid line, meaning that all of these points on the line are included within the solution. Now, what if it was like this? What if it was just all the y values greater than that line? Well, then this line here, instead of a solid line, it would be graphed as a dotted line. All right, and it wouldn't include the points on the line because it's just the y values that are greater than that line. It doesn't include the points on that line, but because it was greater than or equal to, this here was a solid line. Right, so just a couple of things to be on the lookout for when you're solving these. So moving on to number 2, same kind of thing. We got 3x minus 5y is greater than 25. So same thing, what I'm going to do is isolate for the y. I'm going to bring the y over to keep it positive, and then the 25 I'm going to bring over. Just so when we isolate, when we divide everything by 5, we don't have to worry about flipping that sign. And so we would end up with this over here. So all of the y values are less than 3 over 5x minus 5. So another way to write it is like that, right? This and this are the exact same thing, right? So y is less than this, y is less than this. Now, if you isolated for the y by not bringing it over, by keeping it here, then you'd bring the 3x over, turn into a negative 3x plus 25. Then when you divide everything by negative 5, you'd have to flip that sign, and you would end up with this over here. All right, so whichever way you do it, this here is what you should end up with, right? With the y isolated, and now you have this line 3 over 5x minus 5, and so you could graph it. So if we graph this line, we have 0 and negative 5 as the y-intercept if we plug in 0 for x. So let's forget about the inequality for now. Let's pretend we just had this line like this. Right, so 0 and negative 5, that is the y-intercept. If we wanted to get the x-intercept, what we could do is plug in 0 for y, and then isolate for the x. So bring the 5 over, 3x over 5, this is 5 over 1, 1 times 3x is 3x, 25, x would end up being 25 over 3, which would be 8.33, so that would be like over here. So this here would be 25 over 3 and 0. That would be the x-intercept. Connect the dots, and we'd end up with that line over here. Another way you can get these intercepts pretty quickly, if you're given this format, is before worrying about the inequality, getting it into this format, you can say you got 3x minus 5y equals 25. And then from here, you could plug in 0 for x, right? If we plug in 0 for x, we'd end up with negative 5y equals 25. Y would be negative 5, this. And then if we wanted the x-intercept, we could plug in 0 for y. This would go to 0. We'd end up with 3x equals 25, x equals 25 over 3. So we'd end up with that right there. And then you still have to take this, isolate for the y, but before doing that, you can get those intercepts pretty quickly with this kind of format. Because notice here we had to do a bit of algebra, right, to get that x-intercept, versus here, it's probably less. You just divide both. This would go away, and then you just divide both sides by 3. Either way, you're going to get the same answer, but maybe sometimes if it's in this format, you could just plug in 0 for the x and y respectively to get those two intercepts, and then graph the line, and then work with the inequality and get it to this format over here. Right, so whichever way you do it, and again, you don't have to get the intercepts. You can just get a couple of points over here. Whichever way you do it, just make sure you're getting the same graph that I'm getting. Now, here, notice that they're saying y is less than this line. So first off, because it's not less than or equal to, it's just less than, the points on the line are not going to be included. And so this line, what we want to do is we actually want to draw a dotted line to represent that line. And it's all the y values less than this line. So basically, it would be this region under the line over here. And then this region here, it extends all the way to negative infinity and extends this way infinitely, right? So that would be the region, that would be the inequality graphed right there. So basically all of these solutions here, if you picked any point within this region, it would satisfy this inequality. If you picked any point within this region, it wouldn't satisfy this inequality. So again, a common test point is 0 and 0. If we plug it in, 0, 0. Is 0 greater than 25? Well, no, it's not. And that makes sense with what we got, because this, any point in this region shouldn't satisfy the inequality. And then you could pick a point within here, right? So notice the y values here are negative 5, so maybe a point like 1 and negative 6, for example. Right, that would be within this region here. If I plug in 1 for x and then negative 6 for y, what would we get here? We'd get positive 33, and notice how that is greater than 25. So it does make sense. So you could always test out your solutions. Using the origin is a great way, is a quick way to check it. Whether sometimes the origin's not going to be in the solution, like in this case, sometimes it will be in the solution, like it was in this case in number 1. Right, moving on to number 3. Same sort of thing, it's just this one's a little bit, I guess, more complex because there's fractions, but not too bad. Same thing, we want to isolate for the y. Now, a couple of ways you can do this. You can keep the fractions. You can also multiply everything by the lowest common denominator to get rid of the fractions if you don't want to work with them. So the lowest common denominator between 4, 6, and 3 would be 12. So I could take this multiplied by 12, take this multiplied by 12, take this multiplied by 12. Because I'm multiplying by a positive number, we don't have to worry about flipping that inequality sign. So this would end up being 3x minus 2y is greater than 4. So this inequality and this inequality, they're actually the exact same thing. It's the exact same solution. So if you don't want to work with fractions, you can do that. And then isolating for that y may be a bit easier. Then you could just divide everything by 2, and you'd end up with 3 over 2x minus 2. All the y values are less than that. So maybe writing it nicer. we end up with that. Or again, if you kept the y value on this side, you'd have negative 2y is greater than negative 3x plus 4. Divide everything by negative 2 because we're dividing by a negative. You got to flip this sign. So y would be less than positive 3 over 2x minus 2, right? Which is what we got here. So again, multiple ways to get to this point. If you didn't want to get rid of the fractions, what you would do is you'd have 1 over 4x minus 1 over 3 is greater than 1 over 6y. And then to isolate for that y, you would divide everything by 1 over 6, which is the same as multiplying by 6. So you can multiply this by 6, multiply this by 6, multiply this by 6. 6 over 4, 3 over 2x. 6 times 1 over 3 is 2, and then we got the minus here, and then the y would be by itself. Y is less than 3 over 2x minus 2. Right? So again, multiple ways. Just make sure you're getting to that same format over here when you isolate for the y. Now, what we got to do is graph this line. So notice that this line here, it's going to have an intercept at 0, negative 2, right, the b value. And let's actually just use the slope here. So what we're going to do is we're going to rise by 3. So we're going to rise to positive 1, right, from negative 2. If we rise by 3, we'll end up with positive 1. Then we're going to run by 2. So the point would be 2 and 1. Like that. Right, so we got the 0, negative 2, and then the 2 and 1. We could have also got this intercept here, so we could have plugged in 0 for y. Change this to an equation. Bring the 2 over, 3x over 2, and we'd end up, when we cross multiply, we'd end up with 3x equals 4, so x equals 4 over 3, or 1.33, so the intercept is 4 over 3, and 0. Right, you could have also did that there. So different ways, just make sure when you're graphing this line, you're graphing the correct line. And then notice that going back to the inequality, it's y is less than this line. And it's not less than or equal to, it's less than, so we would actually graph this line as a dotted line, because it's not going to include those points, and it's all the y values less than this, so it would basically be this region below the line, all the y values below the line, right there. Right, that would be the answer to number 3. Now moving on to 4 and 5, so x is greater than or equal to negative 5, so this one's pretty easy. It's all the x values. Notice we don't have to isolate for anything here. It's all the x values that are greater than or equal to negative 5. So what you would do, you would draw a vertical line at the x value, negative 5, and it would basically be this region over here, if you filled it all in. Right, so like x equals negative 5, that's a vertical line right here. But the inequality, all the x values that are greater than or equal to negative 5, it would be this. If it was greater than negative 5, then this here would be a dotted line. If it was less than or equal to negative 5, the region would be shaded over here. But it's greater than or equal to negative 5, so it's basically this region right there. And then y is less than 3. Well, we know y is equal to 3. How do we draw that line? Well, that is just a horizontal line. Y equals 3. And because it's all the y values less than 3, not equal to 3, it's a dotted line, and the region that we're looking at is this over here. Right, if it was less than or equal to 3, this would be a solid line. If it was greater than 3, the region would be up here, but it's all the y values that are less than 3. So we have a dotted horizontal line, and then the region, the solution to this inequality is basically the region under that dotted line.